my name is Lee Pound, and this is the Quidio for unit number 6. The basic problem states, the drug AZT was the first drug that seemed effective in delaying the onset of AIDS. Evidence for AZT's effectiveness came from a large randomized comparative experiment. The subjects were 1,300 volunteers who were infected with HIV, the virus that caused AIDS, but did not have AIDS. The study assigned 435 of the subjects at random to take 500 milligrams of AZT each day, and another 335 to take a placebo. The others were assigned to the third treatment, a higher dose of AZT. We will be comparing only the two groups. At the end of the study, 38 placebo subjects and 17 of the AZT subjects had developed AIDS. We want to test the claim that taking AZT lowers the proportion of infected people who will develop AIDS in a given period of time. Part A says state the hypothesis and check that you can safely use the Z procedure. So the first thing we want to do is define the variables that we will be using, or our parameter. And so P subscript P represents the proportion of HIV positive individuals who will develop AIDS if treated with a placebo, and P subscript AZT represents the true proportion of all HIV positive individuals who develop AIDS when treated with the 5 milligrams of AZT daily. So from there we can state our hypothesis. So our null hypothesis would be that the true proportions for both treatments are equal, and the alternate hypothesis would be that the number of people who developed AIDS would be greater if treated with a placebo than when treated with AZT. Then to safely to check if we could safely use the Z-test, we do what's called assumptions. So for normality, independence, and randomization. So for normality, you have to check that the population or the sample size represented by N, when multiplied by the probability of success and failure, so P and Q, result in a value greater than 10. And you have to do that for both the placebo sample and the AZT sample. And when I did that, we got results greater than 10 each time. So that means that our distribution is normal. And next you check for independence. So you do this by checking that oopsie, there we go, that the sample times 10 is less than the population size. So we'd assume that 435 is less than the total number of people, is less than 10 times, 435 times 10 is less than the total population of people treated with AZT. And then lastly, randomization, which was stated in the question that they chose people at random to put into different groups. However, these people were volunteers, so there is slight response bias, so you should proceed with caution. Part B asks, how significant is the evidence that the AZT is effective? So basically what we do here is the rest of phantoms. So we do the test. This is a 2-sample Z-test, and so that would look like this equation right here. And if you were to plug in those numbers, it would look like this. So you have the proportion of placebo minus proportion of AZT over P times Q over N, P times Q over N for placebo and AZT. And that gives you a z-value of 2.926. And if you use your chart at the beginning of your textbook, the z-score table, you should get a p-value of 0.002, which is significantly less than our chosen alpha value of 0.05. From there we can make a statement about its significance. We would say that it's statistically significant because our p-value is less than our alpha value, and so from that we can reject the hoe that the true proportion of people that develop AIDS being treated by the placebo and those being treated by the AZT were the same, because our p-value of less than 0.005 or 0.002 was smaller than our decided alpha value of 0.05. Lastly, Part C says the experiment was double-blind. To explain what this means. So that just simply means that neither the subjects nor the one distributing the treatments, the experimenter, knew which group was which when testing.